positive numbers. Okay, so here we can put certain inputs in this drawing. So this is 1 plus T omega squared, and Gj omega basically is minus arctangent T omega. Okay, so here say omega is very small, so this one basically is equal to 1, and this one 0 degrees, and for omega equal to certain finite numbers, then basically this is certain finite numbers. And again, this would be certain negative finite numbers. And this one, if this argument is finite number, so this number should be in between in the range of minus 0 degrees and minus 90. Okay. So when omega in particular equal to the corner frequencies here, omega equal to T 101. So this one will be equal to 1 squared over 2. And this one will be equal to minus 45 degrees. And when omega approaching to infinity, then this one will be equal to 0. This will be approaching to 90 degrees. So from here we can draw it, and that will be something like this. And this is in the real part of the Gj omega and imaginary part of the Gj omega. So starting from here, when omega equal to 0, so that is 1 here, and the whole things will be something like this. Again, this one we have seen last time. This is the this should be a semicircle, and for the semicircle, with the center at 1/2 and radius equal to 1/2. Okay, and here we can put this one. This is omega equal to 0, and from here omega approaching to infinity here. And at this point, minus 45 is when omega equal to 1 over t. So for this example, I want to show you in specific why this is the half of the circle here. And so the reason is g to omega equal to that one, equal to 1 plus j and t omega. Then we can put into the real part and imaginary part here. So the real part will be equal to 1 plus t squared omega squared, and imaginary part is j times minus omega t and 1 plus t squared omega squared. Okay, so this is the real part, and this is the imaginary part here. So if we do something, kind of play around, and such that the real part minus 1/2, we take the square, and plus the imaginary part and take the square. Basically, we can find it. This is these equations. Okay, and we just tried, and so based upon this equation, then we can tell this is the half of the circle here. Okay, and if you like, you can continue. So from omega to minus infinity to 0, then you can make another circle. But usually, when we plot the Nyquist plot, we only plot the half range, which means in the positive numbers of the omega. Okay. Then the second one we compare is the type 1 system, and GS will be equal to S 1 1 plus Ts. Okay. So here we have, for this system, we have the integrator here. So that is a type 1 system. So in a similar way, we can have omega, and G, say omega will be equal to omega times 1 plus T squared omega squared. And then this one, angle will be equal to, due to the introductions of additional 0, so that will be minus 0 and minus arctangent. So additional minus 0 added up to this one. Okay, so here we can do this quickly. So when omega approaching to 0, this one basically approaching to infinity here. And this one is 90 degrees. When again omega, say if you like, say omega equal to the corner frequency here, so basically this one will be equal to certain finite numbers, and then this is 135 degrees. Okay, so any finite number we're making the any finite when omega approaching to infinity here, then basically this is 0, and then this is minus 180 degrees. Okay, so here you can quickly do these calculations, and so here we can plot it. So that is a real of the Gj omega. So when omega approaching to 0, that is the magnitude go to infinity, and the angle is 90. So basically here, I want to draw this case, and so that magnitude is minus 90. So basically here, down to here, okay? So somehow this one, somehow the asymptote is here, okay, when omega approaching to 0. Then when omega approaching to infinity, the magnitude equal to 0. So basically approach close to the origins. And its approaching angle to that is minus 80. So I would say locally is somehow here, okay? And in between, and that is any finite numbers, and the angle is between 90 and 180. So I would say in between that one is something like this. Okay, so for example here, let me label it. So this one, basically this one is omega approaching to infinity here. So that trend is in this. So you might say omega equal to, 1 over t is 135. So I would say you take the 135 here, the intersections, this angle is 135 degrees. You make the intersection, that will make you omega equal to 1 over t. So that is here. Okay. And then we can go to the, to compare, we can go to the type 2 system. So type 2 system, basically here we have a square in the denominators, and let me try this one, Ts. Okay. So again, we can plot it, omega and G magnitude equal to omega squared 1 plus t squared omega squared, and then Gj omega will equal to minus 180 degrees and minus arctangent t omega. Okay, so the result of this calculation is similar. So again, omega approaching to 0, that is go to infinity, and here is minus 180 degrees. And omega equal to 1 over t, so this is the finite numbers. And this one will be 180 minus 45, so that is 225 degrees. When omega approaching to infinity here, so that is 0. So for this one is 270. So basically this curve will be similar to that one, but we is rotating 90 degrees more clockwise. Okay, so we get that ready, and okay, so now from here again, let me plot this one. So when omega is 0, the magnitude at the very large and starting from -80. So I think that one, the asymptote, that means omega approaching to 0 is about here. Okay, very distant away from the origins. And then we plot this one when the magnitude very close to the origin, and its phase angle is -270. So 270 minus, we measure positive counterclockwise. So minus is -90, -180, and -20, 270. So that is from here. So it's approaching to origin in this way. So in between somehow is something we're connecting to like this. Okay, and again the corner frequencies is at 2 to 5. So from here, if you make this line, so say 45 degrees from here, so this angle from here to here is 2 to 5. Okay, so intersection here will give us omega equal to 1 over t, that is the point there. Okay? So from here you can see, compare basically the curve depends, and also by adding the poles, additional poles here, we're adding one more, basically that kind of tweaking the plot negative 90 degrees in clockwise directions. Here you have two poles, basically it kind of push additional negative 90 degrees.